Hi guys, welcome to Gen Z Edu Tutoring Services. This is like an academy for high school CAPS curriculum. So I hope you guys enjoy your stay here. Please don't forget to like, comment, and subscribe. This is Unko Matlala and I'll be teaching you for this series. I want to do a quick explanation on probability tree diagrams. And the analogy I want to make is that, okay, what I want to explain first is that like every time you're asked questions, especially about probability and stuff, it's okay to relate it to your own life. So say you're a student who sells things at school, or you know students who sell things at school, and let's say one of these things is go slows in this case because I want to use that example. So if that person says to you, I have 3 of the pink color, I have 4 of the brown color, and 5 of the green color, what is the probability of him selling the green ones to you? So we could have it in the context of him selling them without you choosing a flavor. So this person is literally just opening his bag and pulling out a snack, and then whatever snack he takes out, he gives to you. So just think about it in that kind of random sense. I know sometimes when you guys buy, you actually tell them barbecue or beef. Just think about it in a sense that this person is selling from a closed bag. Maybe I go jump the principal teacher. So every time this person says, you go slow check, and then you say I want 1 or 2, you take out, he takes them out randomly. So what is the probability that this person from the bag, he's going to pull out the green? So let me quickly just write it. So in this case, to calculate probability, I think you guys have this foundation. I'm just going to explain it. So in this example, the probability that he will pull out a green one is going to be the number of green divided by total number of go slows. Okay, so in this case, when I'm substituting, we have 5. I said that we have 5 green go slow packets. So the probability that he's going to pull out 1 green is going to be 5 over 5 plus 4, 9 plus 3 is equal to 12. So that's the probability that this person's going to pull out a green packet of snacks. So say now we want to know the probability that that packet of snacks will be pink. You're going to say P pink is equal to the number of pink divided by the total number, which comes out to be 3 over 12, which gives me 4. No, not 4, 1 over 4. So the same thing can be done with the brown. So let me say P brown or barbecue. Let me just write barbecue to make it more deep into the context of the go slow. So the probability of getting barbecue is the number of barbecue snacks they have, which is 4, divided by the total number of snacks, which is this, which gives me 1 over 3. So I hope you guys understand the basic principle of calculating probabilities. And then this is for the scenario where you are buying only one. So let me write it down here. You are buying only one. So I hope you guys understand. Or every time you're buying one, that means this person is gonna take out 1 packet. Let's say this person says, Eddie goes look at 5 rand, and you're like, yeah, I get 5 rand, so just give me 1. So this person is just gonna pull out 1 packet of snacks, and it could be green, it could be pink, or it could be brown, right? So let's say this time you decide, you know what, I have 10 rands, let me buy 2 packets of snacks, right? So say you're buying 2 packets. Let me do this. Say you're buying 2 packets of snacks, right? So this person is gonna put their hand into their bag twice. It's gonna pull out the first packet of snacks, and then it's gonna pull out the second packet of snacks, right? So let's say currently you can either be interested in a flavor, or you could just be interested in all the flavors at once. What I mean is that maybe your favorite snack is the barbecue flavor, right? So we have a scenario where you have a favorite or preferred So I'm gonna say you have preferred A, preferred, or you don't have a preferred. So I'm gonna say no preferred. I say preferred and no preferred to explain to you that you have a situation where you're interested in a specific thing. Like, maybe I'm just interested in barbecue. My favorite is barbecue. I'll say preferred will be barbecue because it's the common one really. When I buy them, I'll buy them later on today. I want the barbecue ones, right? So when I buy, I'm thinking about, this person is going to put their hand in that bag. Every time they put their hand in that bag, it's either I will get the barbecue or I will not get barbecue. So I'll just write not barbecue. Right. So this person put their hand in the bag and they pull out something. So what is the probability that it will be barbecue? The first packet that he pulls out will be barbecue. So the situation that we have here now, because we're just talking about the first one, I will say this is the probability. I hope you guys understand what I mean, because here we were just buying only one, so the situation doesn't change. We're buying only one, he's pulling out the first one, so the situation is still the same, right? So we have barbecue, which the probability of is 1/3, and then the probability that he won't pull out the barbecue snack will be the probability of pulling out pink plus the probability of pulling out green. Why? Because of all these 12 snacks, we have 4 that is barbecue, and then we have 8 that is not barbecue. So it's either you're gonna pull out from this 4 or you're gonna pull out from this 8. So it's barbecue or it's not barbecue. So 8/12 is the probability of not taking out barbecue, which I think is 2 over 8, 12, 2/3. So I have 1/3 and 2/3. So look at this, 2/3. So can you see that the probability, this whole probability, if I were to accumulate it, it gives me 1. So 1/3 plus 2/3 is equal to 3/3, which is 1. Do you guys see this? This is very important to know, because with tree diagrams, everything you have 4 options must add up to 1. So every time you move from this point and divide it, everything that comes to the end of this branch must add up to 1. So in this case, just to reiterate, we have 1/3 and 2/3, which add up to 1. Sharp. So this is for the first. So this is for first packet that he pulls out, right? We have a situation now that I'm buying 2 packets. He's going to put his hand in again and he's going to pull out another packet. Because my favorite is barbecue, I'm interested in I hope he pulls out barbecue, right? So so this one is a probability that he takes out barbecue. So let's say he took out barbecue. What is the probability that the second one will be barbecue? So this is the first option that he had from pulling out the first packet. He's done pulling out the first packet, and then let's say the first packet is barbecue. So if the first packet is barbecue, this is our interest, right? What you do is you spread the 3 branches again, and then you're gonna write, okay, it's either I'm going to get barbecue or I'm not gonna get barbecue in the second option, like the second packet of coleslaws. So the first time I got barbecue, sharp. And then the second time, what is the probability that I'm not gonna get barbecue? Sharp. Let's look at this situation here. If I say I took out, so I have 4 barbecue, right? And I said P barbecue is equal to 4/12, which gave me 1/3. Sharp. If I take out 1 of the barbecues, that means that from that 4, I need to take out 1. I get it the first time I chose barbecue. So that means I have 3 barbecue left for my second option. If I sold barbecue coleslaws, I don't have that coleslaw to sell again. So whatever coleslaw I sell, I'm going to subtract, unless they say with replacement. I think I will explain that in a different video. It's a very simple concept, but since I've started with the without replacement and it's very common, I think I'm just going to continue with this just to avoid the whole procrastination thing on my part. So we have barbecue that I've sold. This is the total I had minus the one I sold, which gives me 3 barbecue. Of the total coleslaws, I have 12 coleslaws in total, right? And I sold 1 coleslaw sold. So that means that the total I have now is 13. I hope you guys understand. I have 13 coleslaws left. So of my options, since I sold 1 out of the 12, and the one that I sold was barbecue, that means that the probability of getting barbecue now will be 3 over 13. Because I get P barbecue is equal to the number of barbecue divided by the number the total number, right? So in this case, after selling that one, the first one, I'm now left with 3 barbecue divided by 13 barbecue, which is my new probability. You understand? So I'm just going to put that here before I move on to explaining the other parts. So the probability here now becomes 3 over 13. Why? Because since the first one I sold was barbecue reduced from 4 to 3. And then since I sold 1 packet of all my coleslaws, I'm left with 13. No, not 13. Why? I'm so sorry. Not 13. I'm left with 11. 3 out of 11. I'm sorry for this mistake. What? It's not 13. It's 11. I am so sorry. So 3 out of 11. 3 out of 11. I hope you guys saw that mistake. I'm correcting it now. And then what is the probability now that it's not barbecue, right? So I sold barbecue. So yes, my total is still 11 since I sold of my total coleslaws, I sold barbecue. And then now is for me to decide of the pink and of the green, did my number of coleslaws change from those options? So I sold barbecue. Since I sold barbecue, this number does not change. I mean, not that number. This number here does not change. That number also does not change. The only number that changes is this one because I sold this one. So let me look at it here. If I sell coleslaws 3 brown, this number does not change and this number does not change. So I still have 8 of the ones that are not barbecue. And then since I sold 1 of the 12, I'm going to have 12 minus 1 here, which gives me 8 over 11 for the option and not coleslaws. I mean, not barbecue. So that's my probability for getting not barbecue. So to be sure if my answer is correct, and making sense according to mathematics, I have to check, okay, from this tree branch, from this point, are all my probabilities equal to 1? So 3 plus 8 over 11 is equal to 11 over 11, which tells me that's okay. That means that my calculations are correct for this branch. Sharp. Now we move to the part where, let's say he pulled out the first packet of coleslaws and it wasn't barbecue, maybe it was pink or it was green, right? So what you can do at this point is that from here, since he took out the first one and it was not coleslaws, you're going to look at what are your options after that. So you still have barbecue coleslaws in that bag. And fortunately enough for you, it's still 4. It's not 3. It's not like the number of barbecue is not reduced. So let's just hypothetically choose that, okay, in this case, this person now took out from the green ones. So for barbecue at this point, you still have 4, but because you sold 1, you still have 12 minus 1 here, which is 4 over 11 for barbecue. But for the option you're not barbecue, can you guys please try pause this video and try to answer it yourself so that you can see if you understand. Whatever you struggle to perceive in this situation, please write it in the comment section. I will try to help you so that we deal with that small issue that you may have with probability that you're not noticing, right? So in the case of not barbecue, at first I said the total was 8. I sold 1. Divide that by the total number of coleslaws after I sold 1. So it's 12 minus the 1 sold, which is equal to 7 over 11. So that's the probability of getting not barbecue. So after taking out the first packet of coleslaws, it was green, so it was not barbecue. This is why the first probability is 2 over 3. And now the second calculation I'm going to make is that for the second packet that he takes out, I get him 10 rand, one is 5 rand. I want 2 packets of coleslaws. For the second packet that he's going to give me, the probability of me getting barbecue is going to become 8 over 11, since the number, not 8, why am I doing this? Okay, 4 over 11, and then the probability of not getting barbecue is now 7 over 11, because I had 8, I sold 1, and I have 7 now. So how are you going to okay, now we can start checking if our calculations are correct. When you take 4 and you add 7 to it, you're going to get 11 over 11. You can check it yourself. So that tells me that, okay, this branch of my tree is correct, because like I said, when you add the branches together, you must get a number of 1. Sharp. So now let's say you have a hypothetical question where they say to you, what is the probability of getting 2 barbecue coleslaws? Right? So that means that I'm going to do P barbecue for the first purchase, and then what you need to know as a rule is that you must multiply that one by the second pick. So every time this person puts his hand into the bag and pulls out coleslaws, you're going to multiply the probability for that round. About making sense. So you're gonna put your hand in the bag and pull out coleslaws. So the probability of getting barbecue for that first round, you're going to put it here, and then the second round that he puts his hand in, you're going to put the probability for that round in here. Okay, so in this case, for where barbecue is my favorite, we're going to look at this and see hore, the probability of him getting barbecue the first time is 1 over 3. So you're going to say equal to 1 over 3 times. For him to get barbecue the second time, you look at your tree. So this is barbecue, shabu 1 over 3. And then for him to get barbecue again, he had a probability of 3 over 11. So it's going to be 3 over 11, which is equal to. So now you just have to multiply everything out, which gives me 3 over 33. Overall, I think it gives me 1 over 11. I hope this is correct. So that's what happens where, if you have a tree diagram, they can always ask you these questions in these ways. So I just want my students to try this question and try to answer it for me. Send it to me via WhatsApp. What is the probability that this person will pick 1 barbecue and 1 not barbecue? So this question looks very simple, but then please think about it deeply. It's either you will pick the barbecue first and then pick the not barbecue, or you're going to pick the not barbecue first and then pick the barbecue again. So I want you guys to try and integrate that whole analogy that I'm explaining to you into one answer. Send it to me, and I definitely want to see how you guys explore this. I will definitely explain it to you guys in one of our Zoom meetings. So from here, I want to explain to you guys the concept of when you do not prefer something. That's where your tree has so many branches. I'm not gonna lie to you. So let's say you're new to this game of go slows, or you're just a very versatile person. So you're not picky with your go slows, right? Every time you draw your tree in this case, when you're not focusing on anything, you would draw the tree with the number of options that you have. So since now we have pink go slows, green go slows, and barbecue go slows, you're gonna have 3 options, meaning your tree will have 3 branches. Be very careful when drawing tree diagrams, because you need to have what can I call it? You need to have space to create more branches, especially if you're going to put your hand in that bag 7 times. Make sure that your space is enough to actually put your hand in that bag 7 times. What I mean is, you're going to have 3 branches. One will be pink, one will be green, one will be brown. I get it, when now you are versatile, you don't have too many options. For your second branch again, you're going to be pink, green, brown. After choosing pink, you're going to have options again, pink, green, brown. And then you're gonna have another option here where if the first pick that you got was green, there you have pink, then you have green, then you have brown. And then another option is that maybe you picked brown first. After more, you still have the options of pink, green, and brown for the second packet that you buy. So here, the only difference is that they're not focused in their question. They're not focused on just the brown packet. They are actually focused on everything, where they can actually ask you, what is the probability of getting 1 pink and 1 green? That way you must integrate that whole concept that I was telling you about. And I think I'm ready to actually explain it to you guys, right? So here, say you are walking along this line. I think I should use a highlighter. Okay, not the highlighter. Say this, you're moving towards a line, probability of pink again. So if you're moving towards along a line, you do P pink times P pink again, right? But every time where you're moving along breaking lines, so let's say it's P pink and P pink, but then at the same time you want to do P green and pink, but at the same time you want to do P brown and pink. That's where they ask you, what is the probability of getting at least 1 pink? At least 1 pink. That means you can get any other thing for the second option, but one of those must be pink. So the probability of that will be P of getting pink and then pink. So since this is along the same line, you're going to multiply these. So it's P pink times pink. I'm going to just put pink in this, P in the second part. And then for this second tree branch, for me to show them that I'm moving towards the second branch, I'm going to add a plus sign. Plus the probability of pulling out green times pulling out pink, plus the probability of pulling out brown times pulling out pink. Right, so I've accounted for this branch here. I'm gonna just color code them, this branch here in this term, and to show them that I'm moving to a different branch, I accounted for this branch here by dividing with a plus sign to have this branch introduced. And then for the last branch, this branch here, I had a plus sign separating everything and then put that branch here. That's how you actually tell them, More, I'm dealing with different branches. And yes, one option is that I'm going to have 2 pink, or I could have green then pink, or I could have brown then pink. All of these is the probability of getting at least 1 pink thing. So I hope you guys understand what I mean here, and this explanation actually helps you to lay out the foundation you need with probability. Please don't forget to like, comment, and subscribe. Ask any questions that you may have in the description box. I will definitely answer you guys in the comment and also as a video to just give you guys context and a simpler way to think about things in terms of this. Otherwise, please have a good rest of the day if you're seeing this in the day. I hope you guys enjoyed this video and do ask me questions. I will post more videos on an exam paper that I wanted to try first, but I had to give you guys this kind of context before trying it. So please do look out for those types of videos, and we'll see you guys later.